Well, g'day, Max here again. Welcome back to the shop. Well, today's video was supposed to be just a straightforward job of machining, correcting the angle on our gib strip to suit our newly machined surfaces on our compound slide. So, last video we measured the angle that we have to machine the gib strip to. So then we proceeded to, well, you haven't seen the footage of this yet, proceeded to machine the gib strip to said angle, and when we did a trial fit, nowhere near. Like, we made a complete peg's ass of this somewhere, and for the life of me, looking and double checking measurements, could not see where we've picked up a massive error. I'm talking an error 13,000ths of an inch difference from one end to the other in error. So we're going to have to go through this. I'll reset the angle of the gib strip again. We'll do some measuring and try and find out exactly what went wrong. Anyway, let's head over to the milling machine and our surface plate, and we'll go through bit by bit. First up, I'll just put the clip in of us setting the gib strip up to do the initial machining on the mag truck in the Bridgeport. So I'll put a quick clip of that, and then we'll go to our into problem solving mode. So looking at our base, which was the last part we machined that you guys saw, we'd done our dovetails and done a minimalistic cleanup on the bottom section, and we got to the stage where we needed to do a measurement just to make sure we're all in a parallel sort of fashion. So that's at 3.9005. So we're half a thou up on 3.9. We'll come down to the other end. And we're about 2/10 up. So we have a 2 to 3/10 variation there. So that's, in the big scheme of things, that is what it is. I'm not gonna correct that. Not in the milling machine anyway. If I wanted to, I'd reset this up, and knock off the high spot. How that's possibly come about, when we machined this, we set this up in the machine, we indicated off the face here, and then we cut this face first. So the direction of travel on our part is in towards the cutter. So then, once that side's complete, we come around to do the other side. We then traverse our part or back towards the cutter. So that's a direction change on the knee of the milling machine. So that'll be where that 2 3/10 error has come in when we've machined it. To take that out, yeah, I would have to rotate around, indicate off this edge and cut this edge, bearing in mind to do the cut and indicating in the same direction, not have a direction change from indicating to cutting, and that will correct that. But it's not enough to worry about. 2 3/10. I'm fine with that. So that's where you will get an error and a direction change on a knee on the milling machine, as the things just can tend to want to cant one way or the other. And you'll find your table will do the same thing sometimes. I had a question asked when we were milling. No, what was this? Yeah, I think. I milled up one side, come down, did a rough cut down the other side, and then came finish cut back up that side. So both our finish cuts were running in the same direction, just to eliminate anything going, any unwanted movement in the machine, which isn't, you'll have a conventional cut one way and a climb cut the other. And I was asked that, why did I climb cut one way and conventional cut the other? Well, that's so my direction of travel was always in the same direction. That's something, when you're working to under 1/1000 of an inch, you've got to really keep, be on the ball with. So anyway, that's this bit done. So let's go and have a look at our gib strip. So if we put our gib strip in as it is, so we have the top part of the compound as far forward as what it would go when it's in the machine. So we can push our gib strip in (45mm). So we'll bring the compound slide all the way back, as far as it would go in the machine, and push it back in again. And we're 48mm. So we've got 3mm. I think we had 4mm of difference before we machined it. So we still have this 3mm variation. So we know for a fact that there is a issue with the angle. So let's get this set up in the Bridgeport and see where the error is. So I know it will be thicker on this end than it should be. So we'll get this set up and then we'll confirm all of that, and then we'll take a skim cut across it. So our setup to machine our gib strip, as you can see, we've got our magnetic chuck set up in the Bridgeport at an angle. So I have a shim just under one end to protect the table, and then I've got a parallel and a copper a brass shim up the other end, and I was just tapping the copper or the parallel strip in further to regulate the angle. So I'll bring you in a bit closer. So to set our desired angle, what we require is over a 5-inch length of travel, our dial indicator has to move 65 thou. So that's one complete turn, and 5, 10, 15 down there. So I'll wind the table 127mm or 5 inches. So that's 127 there, and we're right on where we need to be there. So there is another method to set that same angle, and that's using a sine bar. So the advantage for using a sine bar over relying on your machine's lead screw is with a sine bar you're not going to get any pitch error in your lead screw. If you've got pitch error on a worn lead screw, it's going to alter the distance you think you've moved, and consequently this last number here will be set incorrectly, or you will adjust your fixture incorrectly. So that's one thing to keep in mind. It will throw you out 1, maybe 2 thou. And of course the other thing to keep in mind is to make sure your packing that you have under there is square to the table, and the magnetic chuck is square to the table too. If it's on an angle, you're going to end up machining a bit of a compound angle on our gib strip, so it'll be sort of cocked over to one side. So yeah, the vise has to be parallel with the table, and when we put our gib strip on, that also has to be parallel to the mag chuck. So speaking of sine bars, I don't actually have a conventional one, but I've got this. This turned up in the mail the other day from Jim Enos at Tangent Engineering. And what this is a sine bar for setting compound slide or top slide angle in your lathe. This is the 5-inch model, so it has 2 pins here, 5-inch centers, and 3 magnets here. So as soon as I saw him demonstrate this, I thought to myself, well, this can be used in a lot of my machines and gear other than the lathe as well. So we're going to put it on our mag chuck that we've just set up. You can use it as it's designed for a compound slide on a lathe. You can use it to set the table on a tool and cutter grinder, a universal milling machine. For those not in the know, a universal milling machine has a pivoting table. So yeah, machine vices, I'll try it out in a cylindrical grinder for the table. So yeah, many uses. So yeah, Jim at Tangent Engineering came through with a good one here. He's also the fella that makes these. These are the quill wheels for the milling machines. So yeah, let me get this set up. So all we need to do with this, plonk it on our mag base. Now, because of the depth of this, I'm just going to use 2 sets of gauge blocks. One of them is 65 thou higher than the other one. So the first one will slip under the rear pin, push down, slip the other one under the other pin, push the whole assembly down. So we'll run our indicator along that, and we should get 0, 0. I'll say within half a thou or so, because this magnetic chuck needs a grind, which has had a bit of a sorry life, but we'll see how she comes out. Yeah, so looking from behind, these are the 2 5-inch centre pins and our 2 gauge blocks. So this one being 65 thou taller than the other one will give us a parallel reading there with the table. Okay, yeah, and that's within that's about half a thou variation, if that. You find some of that's the table on my machine, some of that will be this mag chuck. So just another way to verify. So briefly, when you use this tool on your lathe, because I have a fully machined compound slide, it's just a matter of sit it on, push one of the pins in, and of course you use a gauge block under the other end, push it in, and set your compound until your indicator clocks parallel or 0, 0 along here. That's its true use. So we will be using this in this machine when it's up and running, and we'll also show you some, a lot of other uses where this tool can be used around the shop. So we'll get our gib strip set up. Got a pack of roofing contractors working next door. Bloody noisy bastards they are with their screw guns. So hence I've got the door shut here, and we're back to our old lighting woes again. Just a couple of bits of metal just to back up the rear of the gib strip, just to give it a bit more support in case it wants to go walkie-walkies. Make sure she's parallel and down with the mag chuck. So let's see where we're at. So she's starting to rise. So look at about 6.5 thou difference from that end to that end. So that end's thicker. That is actually the thick end of the gib, and going by how it felt, that's where the material needed to come off, and that's what I was originally scraping before we decided to hold fire and do some proper measuring. So now we've got to take it off the other end, but even still, when I slip this in, it does feel to me like it's got to come off this end. But I've double checked all my measurements, so we're just going to run by what the measurements are and see what happens. So I'll get a cutter set up. I'm going to use a high-speed cutter or a carbide end mill. I'm not going to use an insert cutter because I don't want any sort of significant tool pressure, as I do not want this to move on the mag chuck. So yeah, we'll get a cutter set up, and we're just going to take a couple of very light cuts across it. Okay, so going back to where we were, we're just going to go back in time and imagine this gib strip is just been machined, as we've just seen on the video. So I proceeded then to assemble the top half onto the lower half for a trial fit, slipped our gib strip back in, and what we found, we still had no play up one end and a lot of play down the other end, in sideways wiggle when they were assembled. It was actually worse than when we'd started. I think, what did we have when we clocked it up earlier? I think it was something like a 1/6 thou discrepancy. Well, we've doubled that. We've come now to a 13th thou discrepancy error. So we're 13th thou bigger at one end than what we should be. So I thought, what's going on? I could not really picture what was going on. So when we set our angles on our sine bar, and doing it with the lead screw in the milling machine, it's across a 5-inch distance. Now this gib strip measures 9.5 inches. So we're spanning 3/4 of the length of the gib strip. It's not as if we're taking our measurements off a 2-inch sine bar or anything like that. So we are covering a fair percentage of this gib strip. And all of our measurements, every single measurement, we're below 1/2 thou. Even if we had incremental errors, I know they do build up, 1/2 thou here, 1/2 thou there, it's still not enough to put us 13 thou out here. So what I proceeded to do next, and I did this off camera as it was the end of the day, we put our gib strip back in, and I took an exact measurement across the 2 pins right at the very end of the gib strip, and the same up the other end, right at the end of the gib strip. So that's how I worked out we had a 13 thou error. So then I proceeded to reset our mag chuck to take the 13 thou error out. So I set this up in a chuck so it was 0 on the fat end and -13 on the skinny end. Right, so that brought us back where we need to be. So this has just come out of the machine from that machining operation. So what I'm going to show you is now I'll set it back up and we'll see how we're going now. So now we've got our gib strip sitting back in. We've just got a clamp around it because I did have to preset my gauge blocks, and it's clamped because if the gib strip slides up and down, I'll have to reset gauge blocks. I mean, it does give a parallel measurement, but yeah, the width will change. So I've got a stack of gauge blocks here, which is 1.841 inches. So if we come right down the very end, we find they slip in just nicely. So we'll come up the other end. And same deal. We've got this, feels exactly the same. However, we come to the middle, they don't want to go. So I'll take the 0.141 block out of the stack and I'll put in a 0.139. So we're 2 thou under what we had. We'll put that in. That falls in. So we need a 140, which is here. So we'll ring those together. they'll go, but it's tight. So we've got a bit over 1 thou smaller, tighter distance in here. So okay, so exaggerated, it's convexed by just over 1 thou. 1 thou and a couple of tenths is what it is. So I'm thinking, well, where's that come from? At least now we have a parallel measurement. We're good to go on either end of our gib. So we are on the right angle. So let's just flick back to our magnetic chuck for a second. So we're reading in the middle as high. So that could possibly be caused, I was thinking, if the middle of the magnetic chuck maybe was slightly concaved, worn in the middle. So when we put our strip on, it's sucking it down possibly. So what I did then was I have a parallel sitting on the chuck, 3 bits of tally-ho rolly paper. So if I grab the first end one, we're under the parallel. If I grab the second one, we're under the end of it. When I go to the middle one, we've got a hollow. So that just confirms the top of this magnetic chuck does have a slight concave feature to it. So possibly that's what's given us the error, the tight spot in the middle. So I'll just run the scraper across this and I'll scrape that out of it. Okay, well let's remeasure now the angle that our mag chuck is on. Now we know and have confirmed that it has been set to the right angle by our previous measurements that we took end to end. So we'll get an angle, we'll measure it across a 5-inch length and also across the 9.5-inch length. Make sure there's no irregularities there, and also compare these readings to our original readings before I had to reset the chuck. Okay, so we'll check the new angle of our mag chuck, and we're going to do it first off a 5-inch distance. So we move along, well, it's 127 millimeters on my metric machine. So we go 5, 10, 15, 20, 25, 30, 35, 40, 50, 60, 70, 80, 90, 100, 5, 10, 15, 20, 25, 26, 127. So that gives us a reading of 56.25 thou. So over 5 inches. I'll call that 56.5. We'll just round it up. So what we'll do now is we'll reset and we'll get an angle measurement using that 56.5 thou with our sine plate. So with our sine bar set up, we have a stack of blocks 56.25 thou higher here than here. Now this should replicate our angle and we should get a parallel reading across the top of the sine bar. We move across, we see our indicator dropping off. We'll get back to that in a sec. And our indicator is rising back up to 0. So we're 0 and 0 above the 2 points in the sine bar. We come to the middle of the sine bar. We're low by 1/2 thou. So this sine bar between the 2 pins has a dip in it of 1/2 thou. Now I've verified this with a straight edge, our parallel strip. for what this thing is designed to do, that half a thou in the middle is negligible because you're measuring from end to end anyway. When our Jung HF50 surface grinder is up and running, I think I'll pop this in the surface grinder, mount it on the pins, and we'll just grind the top of this just to take this error out of that. But okay, this confirms our lead screw measurements of that we did to set the angle of our magnetic chuck. So we can now work out through trig the difference in angles between our initial machining of the gib strip and our last machining of the gib strip, and we'll just check our angle difference there. So this measurement's going to span the entire length of the gib strip, which is 9.5 inches long, or 241.3. So we'll traverse the table across 241.3 and see what our indicator reads. That way we get a measurement to compare to our sine bar reading as well. Doesn't hurt to do things in triplicate. Okay, so I'll traverse along. It's 50 thou. Hundred thou. Okay, that's 240, 241.3. We've come up with a reading of 107 thou. So I'll write those figures down and we'll go and do some trig. Okay, so now where are we with this error? So we've ended up between our original readings that we took at the end of the previous video, or the video before that, where we measured these angles, we've ended up with an 8 7/10 thou discrepancy over a 5-inch length, which equates to 0.0996 degrees, or 5 minutes 58.56 seconds. So our old angle, the original angle that we measured, was 0.7448 degrees, which is 44 minutes 41.28 seconds. And our new angle, 0.6452 degrees, which is 38 minutes 43.08 seconds, you know, give or take, but that's a fair whack. 8 thou on our 5-inch length. All our measurements when we set this up were all well within half a thou. We didn't encroach over half a thou for anything. So well, I'm at a loss. I'm at a complete loss. I cannot see where that error has crept in. So that being said, the main thing now is we do have the correct angle. I think I'm going to do some scraping on this gib just to take that hump out of the middle, and then we'll put this together. We'll have a test fit with some bluing compound and see how we go. Okay, now that we're all thoroughly confused, I'm just going to put a quick clip in here from the previous video showing us taking the angle measurement across here, because that is what every single measurement is based on. So we wind the table in, and then the reading we need is the direct reading off this dial when this one reaches 0. So we wind in, so we're 25, 30, 35, 40, 45, 50, 55, 60, 63, 64, 65, yeah, 65 thou. So the 65 thou forms the other leg of the triangle. So we have a right angle triangle, the 5-inch leg that way, 65 thou leg that way. So we can put those numbers in using trigonometry and calculate our angle. So just for another last check, I did remount the top half of the compound slide in the Bridgeport, and we come up with the exact same result, 65 thou over a 5-inch length. So I just wanted to double check it just to make sure like something silly hadn't happened, like I was actually pushing the dowel pin up against the dovetail, just to confirm that. And yeah, we had the right measurement from the start. So it just eliminates something silly. So yes, well, we might just end this video here now that we're all thoroughly confused. Maybe not. And you see my dilemma. I mean, honestly, I'm at a complete loss. So what I'll do is I'll go ahead and yeah, obviously we'll finish this one here. And yeah, the next one we'll do all the necessary scraping, and hopefully that should be straightforward, and a straightforward reassembly of the compound slide. Then I can wash my hands off it, put it to one side, job's right. So yeah, anyway, thanks for watching, and we'll see us in the next video. Cheers.